Welcome to Swatantra Education. In this lecture, we are going to discuss about the concept of double linked list. So, previously we have discussed about the single linked list, and the structure of the single linked list is like this. So, here you can see, so in single linked list we have one data part and one link part, or you can say the reference part, and the link or reference refers to the next node. So, the structure is like this. So, here you can observe A refers to B, B refers to C, C refers to D, and the link of D is null. That means D is not going to refer any other node, and we have one reference head or start that refers to A. So, this is the structure of single linked list. So, we have already discussed about the concept of single linked list. So, what are the limitations of single linked list? So that we have to consider another type of linked list. So, the limitation here is that from A we can move to B, from B we can move to C, from C we can move to D, and from D we cannot move to other node because D is the last node. But here we can observe from B we cannot move to A. So, this is not possible. Similarly, from C we cannot move to B. That means we cannot traverse backward along the list because the list does not store any reference about the previous nodes. So, we cannot move backward along the list, but some applications of linked list require that we frequently move both forward and backward through the list. So, in that applications the single linked list is not applicable. So, what are the solution? So, there are multiple solutions or multiple approaches to traverse along the backward direction in a single list or in a linked list. There are multiple approaches to traverse in the backward direction of a linked list, but the simplest, most flexible and satisfying strategy is to keep two links in each node. So, here you can observe, if this is a node, then it has only one link, this part that refers to node B. Similarly, if this is a node, then it has only one link that is going to refer to the next node. Now, if we keep two links in each node, then we can easily traverse both in forward direction and backward direction. That means the structure will be like this. Suppose the data is A and another node that contains data B, and another node that contains data C, and another node that contains data D. Now, each node have two links. That means one link refers to the next node, and here the next of D is null, and another link refers to the previous node. So, like this, this one, this one, this one, and here the previous of A is null, and we have a reference head that is going to refer to A. So, here you can observe this link refers to the next node and this link refers to the previous node. Similarly, or let me write here, this one is the link to the next node and this one is the link to the previous node. Now, if this is a node, then for each node we have two links or two references, one for next, another one is for previous. So, as we move both in forward and backward direction, so you may tell like this one is also next, this one is also we can consider next. So, you may better call left right, or most of the authors have used the notation next and previous. So, next one is this one and previous is this one, or you can say left right, no issues. So, that means in each node we can keep two links. So, better you can see this figure for clear understanding. So, here this one is one node, and assume this is the head. So this one is head or start, and here this is one node, this is another node, this is another node. So one node or this node has reference to next, similarly this node has reference to next, similarly the previous reference of this node is null, and the previous of this node is this one, similarly the previous of this node is this one. Here you can see. So if we keep two links in a node like this structure, then we can easily move or easily traverse both forward and backward direction through the list, and such a list is called as double linked list. So such type of structure or such type of list is called as double linked list. Then how to define a node in Java? Suppose we want to write the definition of node in Java. So for that we can create a class node. So like previously we have discussed, so we can write like this, class node, and suppose we are keeping only one character value in each node, and assume the variable name is data. So we are writing char data. Now in addition to the data, we have to write two reference variables or two links we can consider, and that are referring to another node, or the type of the link will be node. So for that we can write node next and node prev. I am writing prev for previous, or you can write previous or left right in place of next and previous, anything you want to write you can write, but the concept is important. Now you can use a constructor for initialization of the node. So you can write node and pass the character value as a parameter for the constructor, and here we can write this dot data equal to data, and if you want to initialize this next and previous you can write as null, or you can give some values also, so no issues. Okay, so end of constructor. So this one is the constructor for the node class. So here you can see the node has three members or three attributes. One is data, another one is a reference next, another one is a reference previous. So this is the constructor. Now we can end, or we can give a curly braces to end the, or that denotes the end of the class node. So here you can observe this is all about the class node. So now we can discuss some methods for double linked list. So what are the methods? So like we have discussed in single linked list, the methods we can consider like insertion, and for insertion there are three cases, like case 1 insertion at first or insert at beginning, and case 2 that is insert at last or insert at the end, and we can consider another case for insertion that is insert at a given position, or we can say insert in the middle. Middle means not exactly middle, that is any given position. Similarly, another method or another operation associated with this double linked list is deletion. That means if we want to delete a node from a linked list, and here also in case 1 we can consider delete the first node, and in case 2 we can consider delete the last node, and another one is delete the node at a given position, or we can say delete a key, or we can say delete from middle. Now we are going to discuss another operation or method that is associated with the double linked list, that is traverse. That means move from head to the tail or move from start to the end and display the elements, or like that, or how we can move from one node to another node. So, that is all about traversing or traversing a linked list. Now, we are going to discuss the method, that is how to insert a node at first, or how to insert a node at the beginning of a double linked list. So, let me write that one. So, insert at first. So, consider the linked list is like this. So, this is one node, this is another node, this is another node. So, assume 3 nodes are there. So, here data is A, here data is B, here data is C. So, the next of A is B, the next of B is C, and the next of C is null. Similarly, the previous of C is B, the previous of B is A, and the previous of A is null. And we have one reference head that is going to refer to the first node, that is A. So, initially the double linked list is like this. Now, we want to insert a node, that is P. Suppose we want to insert a node, new node P here. So, if we insert a node P at the beginning, so what will be the structure? So, the structure becomes like this. So, here you can observe. So, P is there, and assume this is A, this is B, this is C. So, the next of C is null, the next of A is B, next of B is C, the previous of C is B, previous of B is A, and the previous of A is P, the next of P is A, and the previous of P is null, and now head is going to refer to P. So, this is the initial condition, and this is the pictorial representation when we insert the node P at the beginning. So, I hope the pictorial representation is clear. So, it is initial. So, here you can see this one is the initial representation, and this one is after insertion. So, after insertion the linked list will be like this. Now, we are going to discuss the steps so that we can easily insert one node at the beginning here. So, now we are going to discuss the steps that we need to follow for this insertion at beginning. So, let me erase these things so that we will start again from the beginning. Okay. So, now we want to insert a node P at the beginning of this double linked list. So, what is the first step? The first step is create the node. So, here we create the node, and this node has the data P, and assume this is the existing linked list here. This one is the existing linked list, it is already there. So, we create the node P. Now, update. So, when we create the node, new node, the data is P, and the previous of P and the next of P both are null. Now, update the next of P, that is going to refer to this one A. So, what is A? A means the node that is referred by head. So, head is referring to A. Now, update the next of P, that is going to refer to head. That means update the next of P, that is going to refer to the current head. So, we can write like this. So, we update the next of P, that is going to refer to the current head, or we can say that is going to refer to A. Now, what is the second step, or what is the next step? So, in the next step you can observe here the previous of A is null, or we can say the previous of the node that is referred by head is null. So update this previous of A, that means update the previous of the node that is referred by head, so that this previous is going to refer to P or to the newly created node. So we can remove this one from here, and this previous is going to refer to this one, to node P. Now what is the next step? So in the next step we are going to update the head. So head is referring to this A. Now we are going to update the head so that it is going to refer to P. So just update the head, that means head is now going to refer to this one. So here you can observe, this is the condition, or this is the pictorial representation after we insert a node P at the beginning. And here one thing you need to mark, that the previous of P is null. So when we create the new node, so the previous of the new node and the next of the new node also null. So both previous and next are null when we create a new node. So now we are going to write the steps that we have discussed just now. So what is the first step? So the first step is create the new node, create newest node. What is the second step? In second step we have done this one, update the next of the newest node so that it is going to refer to the current head. So we can write like this, update the next of newest node. Then what is the next step? So in step 3, we are going to update the previous of this first node, or the previous of the node that is referred by head. So that thing we want to write, set the previous or update the previous of the current head to point to the, or to refer to the newest node. Then what is the next step that we have discussed? So for this step the condition is that the list is not empty. So if the list is not empty, so for step 3 the list should not be empty, otherwise this updation of this previous is not required. Okay. Now what is the next step? In step 4 you can write update the head, like we have discussed, update the head. So these are the 4 steps we need to follow to insert a node at the beginning or insert a node at first. So we can write the complete method for this. So assume if you want to write the method, so we are going to follow these steps in the method. So public void, assume the method name is add first, then we have to pass the data or character value that is required. This character value is required for creation of the new node. So the first step is we have to create the node. So we can write like this, node newest equal to new node and pass the data here. Now update the next of the newest node, and that is going to refer to the head. So for that we can write newest dot next. So newest node dot next, or the next of the newest node, is going to refer to the current head. So initially the head is going to refer to this one, so the next of this newly created node is going to refer to the head. So this thing we want to write, newest dot next will be head. Then what is the next step? So in the next step we can write if the head is not null, if the head is not null, that means if the list is not empty, update the previous. So which node previous? The head nodes previous, or the node that is referred by head. So we can write head dot previous equal to newest. Then what is the next step? So in next step we can update the head. So here we can update the head, and head is going to refer to the new node. So we can write head equal to newest. So this is the end of the method. So here you can see this is the method that we need to write while we want to insert a node at the beginning of a double linked list. So if you understood this one, this method, please write understood in the comment. So here these are the steps, and following these steps we have written this method, and this is the pictorial representation. So I hope this is clear. So now we will discuss another case of insertion, that is insert at end. So let me write that one. So now we will discuss the case 2, that is insert at end. So the new node will be the last node. So assume the list is like this. So for simplicity we are considering initially we have 3 nodes. So assume it is A, assume it is B, assume it is C. So the next of A is B, the previous of B is A, the next of B is C, the previous of C is B, and the next of C is null, the previous of A is null, and head is going to refer to this one, to A. This is the initial structure. This is the initial structure. Now we want to insert a node, assume P at the end. So if we want to insert a node at the end, then what is going to happen? So here you can observe. So let me copy this thing so that it will be more clear. Okay. So if we insert another node at the end, so assume the node is P. So when we create the node, both the next and previous reference are null. Now in the next step we update this next of this one, next of this C, and the next of C is going to refer to this one, to P. So for that we can remove this one here, and it is going to refer to this one, and the previous of this P is going to refer to C, so that we can write this one. Okay. And the next of P will be null as it is, because this one is the last node. So this is the pictorial representation, and you can write head here. So head is referring to this one. So this is the pictorial representation when we want to insert a node at last. That means you can observe here at last P is inserted, and the previously the next of C was null. Now the next of C is referring to the node P, and the previous of P is referring to C. So now we will discuss the steps. So what are the steps we need to follow? So first step is here create the node newest. So the first one is similar to the previous. Here we have to create the new node and assume the name of the node is newest. Then in the next step, or in step 2, we can write find the tail node or find the last node. Find the tail node. So we can use a reference like head. We can use another reference that is going to keep track of the tail node. Like head here, we can take another reference tail that is going to keep track of the tail node, or you can traverse from the start and we find the tail node at the end. So in both the ways you can find the tail node. Then what is the next step? So in step 3 we can update the previous of the newest node. So we can write like this: update previous of newest node. So in the next step, update next of tail node. And what is the next step? So if you take any extra reference for tail node, then update the tail node. So if you are not taking any extra reference like head, then do not update this tail node. So if you are taking one extra reference like head, you are taking one extra reference tail to keep track of the tail node, then you can write this one, update the tail node. Otherwise this one is not required. If you are not taking any extra reference, you are only taking the reference head, then this tail node, updation of the tail node is not required. So it is an optional step. Now we can write the method using these steps. So assume the name of the method is add last. So we can write public void add last and care data. Now first we create the node. So node newest equal to new node and pass this data. Now here you can observe, if the list is empty, that means if no node is there, then this one is the this newest node is the last node. Or you can say, if the list is empty, this newest node is the first node, this newest node is the last node. So we can write like this: if head equal to null, that means the list is empty, then head equal to newest, that means head is going to refer to the newly created node, that means the newest. Else part, that means if the list is not empty, some nodes are already there, then what is the step we need to follow? So update the find the tail node. So assume we have the tail node, then update the previous of the newest node. So what will be the previous of the newest node? So the previous of the newest node will be the tail node. So this one is the tail node. Assume anyway, by any means we find the tail node. So this is the tail node. Now the previous of the newest node will be the tail one. That thing we have written. So update previous of the newest node. So here the previous of the newest node will be the tail, that means this one. Then in the next step, update the next of the tail node, that means we are going to update the next of this one. And in the next step, update the tail node, that means this tail becomes this one. So these are the steps we have already discussed. So assume by any means, by traversing or by taking one extra reference variable, we have the tail node. So in the else part we can write else newest dot previous equal to tail, and then the next of the tail node we have to update tail dot next equal to newest. So this is the end of else part, then the end of the method. Now how to find this tail node? How to find the tail node if we do not have any extra reference? How to find this tail node if we do not have any extra reference? So we can take a reference current and start from the head and traverse through the list until we reach the end. So here we can write to find the tail node. So we can take one reference variable ptr, and initially ptr is head. Then we can write here while ptr dot next, not equal to null, ptr equal to ptr dot next, and when the loop terminates, at that time the node that is referred by ptr will be the tail node. So after the loop, here we can write tail equal to ptr. So in this way we can find the tail node if we are not taking any extra reference variable for the tail. So similar to the single linked list, in single linked list we have discussed the same concept. So I hope this one is clear. If you understood, then in the comment write understood. Now we are going to discuss another type of insertion, that is insertion at middle or insert at any given position. So let me write this thing. So insert at middle, insert at middle or any position, if the position is given. So you can insert the node on the given position of a linked list. So assume we have a linked list and the linked list is like this. So here we have one node and another node, we have another node and we have another node. So assume this is A, B, C, D. The next of D is null, the next of C is D, the previous of D is C. Similarly, you can write the next and previous. And head is going to refer to this one, to A. So assume this is the given linked list. Now we want to insert a node at the middle, that means here we want to insert a node that is after C. So let the node is P. So first create the new node. So when we create the new node, both the previous and next reference are null. Now we want to insert the node after C and before D. So first traverse from the beginning or traverse from here and reach C. We want to add the node P after C. So assume this one is the current. So this is the current. So we can take a reference variable and start from head or start from the first node and reach the node just before the newly inserted node we want to insert, or just before the position where we want to insert the new node. Now update this next of the newest node so that it is going to refer to D. That means update the next of P and it is going to refer to current dot next. So current is this one C. So current dot next will be D. So update this one to current dot next. So we can write like this. So in place of this null, first update this one. Then here you can observe the previous of this D is referring to C or is referring to current. So update the previous of this D so that it is going to refer to this one. So let me remove this part and the previous is going to refer here. Now update the previous of the newly created node. So here you can observe the previous of the newly created node is null. So update the previous node and it is going to refer now to current. So let me remove this one. So it is going to refer to the C or to the current. Now we have to update another thing, that is the current dot next here is referring to D. So update this one so that it is going to refer to P. That means remove this one and the next is going to refer to this one. So in this way we can insert a node P at the middle or at the given position. So what are the steps here? So first we create the node, and in the next step here you can observe this is step 2, we update the next of the newest node. Then this is step 3, we update the previous of the node D. Then what is the step 4? So we update the previous of the new node or newly created node. And what is the step 5? So in step 5 we update the next of the node C. So these are the steps we need to follow for inserting a node at any given position of a linked list. So what are the steps we need to write here? So if the pictorial representation is clear, now we can easily write the steps. So what is the steps, or what are the steps we have to follow? So first create the node newest, create node newest. Then what is the next step? So take a reference current and start from the beginning. So set current, we are taking one extra reference variable current, and set current to point to the head of the list. Now what is the next step? So traverse through the list to find the node that is at position -1. So we need to write this one. So traverse the list to find the node at position -1. So POS is the position where we want to insert the new node. Now what is the step 4? What is the step 4? So in step 4 we can write insert the new node between the current node and the next node. So here we want to insert the node between the current node, So now the current is at position -1. So between the current node and next node. Next node means the next of current. So first we have to find the previous of the node or the node that is at position -1. So first we have to find the node that is at position -1 if we want to insert the new node at position. So here current refers to the previous of the node or the node that is at position -1. So we want to insert the new node at this one current and its next, in between current and its next. So here the new node is inserted and the structure is changed like we have discussed. Then what is the step 5? So in step 5 set the next of newest. Then what is step 6? Set the previous of the next node. Then what is 7? So set the previous of the newest, previous of the newest, and 8 set the next of current. So these are the 8 steps we need to follow if we want to insert a node at a given position or at middle. So this 2, 3, 4, 5, here you can refer this one 5, 6, 7, 8. So these 5, 6, 7, 8 are here written as 2, 3, 4, 5. So now we will write the method for these steps that we have discussed just now, these 8 steps. So the method can be like this. So we can write public void, assume the method name is add any any means any position. Now here in the parameter we need to give the value of the position, that is one integer value, and one character it is taking, that is data, that is the data part of the new node. Now what is the step 1? So first create the node newest. So here we have to write that one. So node newest equal to new node we can write like previously we have written. So node newest equal to new node and pass the data. Sorry, the curly braces is not required here. Okay. Now what is the next step? The next step is set current to point to the head of the list. So here we can write this one. So we can write node current equal to head, that means we are taking one reference variable current that is going to refer to the first node of the list. Now we need to traverse through the list to find the node that is at position -1. So here the next step, traverse the list to find the node at position -1. So for traversing the list we can use a for loop or any other loop you can write. So for we can write int I equal to 0, I less than position -1, I plus plus, then current equal to current dot next. So in this way we can find the node that is just before the position. Now once we find the node just before the position, that means here we reach at C. So now current refers to this C. So what is the first step? So first update this next of P or update the next of newest, and it is going to refer to D. To D means current dot next. So previously this previously we have the structure like this. So let me take this one. So previously the next of C was D. So update this next of P or next of newest so that it is going to refer to D, that means it is going to refer to the next of current. So next of current means D previously or initially the next of C was D. So we can write that one here. So newest dot next. So once we find the node that is just before the position, we can write newest dot next equal to current dot next. So current dot next means this one, this node D, because if this is the current, its next is D. So the newest next of newest is going to refer to D, or newest dot next is going to refer to current dot next. Current dot next is D initial. Okay, so that thing we have written newest dot next equal to current dot next. Now we want to update the previous of this one, the previous of D. So the previous of D means which node's previous? The current dot next previous, and its previous is going to refer to the newest node, that is P. So which node's previous? D is previous. So what is D? So D means if C is current, then D is current dot next initially. So that thing we are going to write here, current dot next dot previous. So the previous of current dot next, that means the previous of D. So this one is D in our example. So the previous of D is going to refer to the newest node. So here we can write newest. Now these steps complete. So here you can observe the step 3 and step 2 complete. Now we are going to move this step 4, 5, that means update the previous of the newest and update the next of the C. So for that we can write like this, the previous of the newest. So we can write newest dot previous. So newest dot previous is going to refer which node? So here this previous is going to refer C. C means the current. So here you can observe current is referring to C, or current is referring to the node that is position -1. So we can write newest dot previous equal to current. Now another thing we want to update, that is this step 5. What is step 5? The next of C. Next of C means the next of current. So what is the next of current? The next of current will be the new node. So here we can write, current dot next will be current dot next equal to newest. So this end of method. So this is the method for inserting this one, for inserting a node in the middle or inserting a node at any given position, and these are the steps we have just discussed, and this is the method. So I hope this one is clear, and if it is clear, write understood in the comment. So this is the pictorial representation. So first create the new node, then traverse from the beginning and reach the node that is at position -1, then just update the next and previous of the new node, and its next, its previous. So this is a simple one. So if you understood this one, that means if the position is given and you can insert at given position like position 3, position 4, position 5, like that, then you can insert, or you can write the method for inserting the newest node after a node, or we can write for inserting the new node before a node. So inserting after a node, inserting before a node is similar to this one.